This is Jack Jackson with the third of our series of videos on inverse trigonometric functions. Today we're going to be talking about defining the arctangent function. So once again I have a coordinate grid going here, and we can start by looking at y equals tangent of x. As with the other trig functions, notice that this trig function is periodic, so it's not one-to-one. So if we graph y equals x and then reflect over that line, we could get x equals tangent of y, but that's definitely not a function. So we want to just only keep a portion of this. So which portion do we want to keep? Well, we want to keep this part between x going from 0 to pi over 2, which corresponds to acute angles, and then we want to keep another piece. Now, in this case, it would make sense to either go from 0 to pi or negative pi over 2 to pi over 2, because in either case we would keep actually one full period of tangent and all the y values would be used once. But which do you think we would want to do? Would we want to keep this piece and this one down here, or keep this piece and this one here? Well, given the choice, we'd rather have one continuous piece here. So we decided to restrict it only between negative pi over 2 and pi over 2, so that we have one connected piece. And so that if we take only that part of the tangent function and do its inverse, we get the arctangent function. And so just as the tangent with this restriction is part of the full tangent function, where it includes all the y values once, it is a one-to-one function, actually increasing function. Then this y equals arctangent function is part of the x equals tangent of y relation, which is not a function, and so we just keep this piece here. Notice that this piece of the tangent function has a vertical asymptote here at x equals pi over 2. Let me see if I can get there. We get a grid line going there, and so you can see this grid line, this one right here is a vertical asymptote, and this one at negative pi over 2 is also vertical asymptote. So that's going to correspond, when we flip it over, to horizontal asymptotes at y equals negative pi over 2 and y equals pi over 2. So these right here are going to be horizontal asymptotes for the arctangent. Notice the range of the tangent is all reals, so the domain of the arctangent is all reals. And again, we can use notations arctan or tan negative 1 there, the inverse tangent, or these other notations. So if we look at some properties now, what kind of properties do we have? Let's get rid of the tangent function altogether, and the restricted tangent, we'll get rid of that. And now what we're left with is just the arctangent function there. Okay. What do you notice about it? Well, it's defined for all reals, so the input can be any value, because the input has to be a value, an output value of tangent, which can be any real number. Then the output of the arctangent is a value between negative pi over 2 and pi over 2. If we're thinking over here in the unit circle picture, that's going to be some angle here between negative pi over 2 and pi over 2. So terminal side in the first or fourth quadrant, but not only just a terminal side in those quadrants, specifically one between negative pi over 2 and pi over 2. If we look at the graph shape a little bit more closely, we see it's one connected piece. It's increasing the whole way, and so it's continuous, increasing, and one-to-one, and it is a function. It has an inflection point. The x and y axes intercepts are the only one is at the origin, which also is an inflection point. When x is negative, we get y values between negative pi over 2 and pi over 2 and 0, and the graph over here is in the third quadrant in this graph, and it's concave up. But if we get x is positive over here in this graph, we start with a tangent who is positive and take its arctangent, we're going to get an output, which over here is an angle, an acute angle, and over here that's a positive output between 0 and pi over 2 for a y value. And notice the graph is concave down in that part of the graph. And there is, and this should say arctangent. Let's fix that. And the output is a measure of a rotational angle in radians that's something between negative pi over 2 and pi over 2. Notice the range is negative pi over 2 to pi over 2, but it does not include negative pi over 2 or pi over 2 because there is no, there is no tangent for those angles, right? The tangent doesn't even exist, so there's no way to get an output with those things. So those are the places. Those are x values. There, that the tangent function would have vertical asymptotes. Those are the y values that the arctangent has horizontal asymptotes. So there we have the arctangent or inverse tangent function. Notice that we do have a button for that here. So if I said, what is the, say, the inverse tangent of -1, of course we're going to get something. Do you recognize that? That is negative pi over 4 on the unit circle picture. That would be something like that for the angle. Okay, so that is the arctangent function. Introduction to that.